this video we will discuss an applet that is developed by Colorado, and this applet shows us very nice where are the magnetic field lines around the magnet, and it's nice to see because we can hover the compass around the magnetic field, and we will see that the magnetic South Pole is attracted to the North Pole of the compass. This we can use to find the direction of the magnetic field line. When we want to draw the magnetic field line, it is the direction of the North Pole. So at different places we can place the compass and draw the magnetic field. So it shows clearly how we can find the magnetic field. Okay. We can hover the compass around the magnet and see the direction of the magnetic field. How is the magnetic field inside a magnet? The magnetic field inside the magnet is from the South Pole to the North Pole. We can use a magnetic field meter to find the strength of the magnetic field at different places around the magnet. When we hover the magnetic field around the magnet, we see that the values will change. And we look at the value here. So when we move the magnetic field meter closer to the magnetic poles, we see that this value is going to increase. We can do the same for the other magnetic pole. So, the compass tells us about the direction of the magnetic field. The field meter tells us about the magnetic field strength. Now, what can you tell about the spacing of the magnetic field when we are closer to the poles or further away from the poles? When we are close to the magnetic poles, the field strength is the strongest. That means also that the magnetic fields have the lowest spacing. When the magnetic field has a lower value, that means that the spacing between the magnetic fields increases. That means also the magnetic field strength decreases. We can also use an electromagnet. And how can you make an electromagnet? You just have to let a current go through a series of coils, which we call a solenoid. And it acts exactly the same as a permanent magnet. So, the electromagnet also creates a magnetic field around the coils. So in this case we see on the left side of the coil the magnetic pole is south. When we move or hover the compass around the electromagnet, we see that the field direction is changing, and here we have now the magnetic North Pole. So it acts exactly the same as a permanent magnet. When we move the magnetic field meter closer to the poles, because an electromagnet also has poles, we see that the magnetic field strength is the strongest close to the poles. Move away, you will see that the values dramatically decrease. And we can do exactly the same for the other pole. Permanent magnet is just like a permanent magnet. There's not a lot of changes you can do. However, you can change the strength of the magnetic field of an electromagnet by changing the voltage and the current. So when we look at the voltage, in this case of a cell, when we decrease the voltage, we see that the magnetic field decreases. When we increase the voltage, we see that the magnetic field increases. This has a big advantage because you can control the magnet. You actually can turn off the magnet whenever you want, and you can turn on the magnet whenever you want. And this has a lot of advantages.